Hello and welcome. Today it's going to be a bit of a war story, and for context, if anyone encounters this and doesn't know me or what I do, I run an internet search engine out of my living room on PC hardware on domestic broadband, and it's like ground up search engine. It doesn't use command crawl and it doesn't use Elasticsearch or anything like that, and it definitely isn't a meta search engine. So I've made some changes to the crawler, and I made them like a month ago. And the changes are twofold. First of all, I added sitemap support, and the sitemaps are XML files that are pointed out, for example, in the robots.txt, which contain a list of addresses on your web server. And this is useful for webmasters because they're able to let the search engine know which links exist, and the search engine gets an easier time indexing the website and so on. There are a couple of things to know about sitemaps, which is that there's an upper limit on how many addresses you can have per XML file, and if you have more than that, then you can link to other XML files from your sitemap. The other change I made was to make a step toward incremental crawling. And the point of that is to instead of doing what I've been doing, is to crawl from scratch every time I crawl. Use the fact that I have old crawl data, and maybe I don't need to visit every link. And there are a couple of ways you can accomplish this, and the easiest is to at least play along a bit with the cache, or rather the caches, HTTP caches. And to this effect, there are two headers that the server will send you when you request content, and one is called etag, and the other contains I don't remember the name of the other, last modifier or something, which contains like the modification time of the content. When you request content again, you can provide this etag and this date and let the server tell you that this hasn't changed, and then you don't need to fetch it. That's very convenient. So this is the other change I made. But as I mentioned, this was a while back. So I needed to wait because you don't want to recrawl too aggressively or too often. This is bad because it annoys webmasters, and then you get blocked, or you end up in robots.txt or whatever. So you don't want to do that, and you ideally don't want to start and stop the crawler too often. So I started the crawl a couple of days ago, and it seemed to work fine. It ran fast. And I crawled, and then I looked at the logs before I went to bed, and it looked fine. And then I woke up the next morning, and everything was on fire. Basically, what seemed to have happened was that the garbage collector wasn't happy. It tried to the Java allocator tried to allocate memory, but the garbage collector was too slow, so it started killing threads. There's a component called the GC locker, and as far as I understand, it has to do with native code as well. But this is a bit strange, I figured, because why is it using more memory? I mean, on some level, I guess it makes sense that since I'm reading the all crawl data along with essentially the same data I'm fetching, maybe like it will double the memory consumption or something. So my first stab at the problem, and it should be mentioned that yes, I know about heap dumps, but the Java process was so far gone it wasn't possible to extract a heap dump. And in my infinite wisdom, I hadn't set the flag that makes it create a heap dump if it runs out of memory. And it actually wasn't running out of memory in the traditional sense. In the garbage collector, was just choking up. So I wasn't able to grab a heap dump. But I figured since I'm basically loading twice the amount of data in memory, maybe I should have the number of threads. This like makes sense, I guess. So said and done. I have the number of threads. I had it at 512 threads before, and I set it to 256. And keep in mind that like these threads are active like once a second, and then they fetch a document, and then they do nothing. So I don't need like a 1,000 core CPU or something like that, or a cluster. And I think most of them are idle most of the time. And like the crawler, even at 256 threads, isn't really using all that much memory. But I sent it off, and yet again, it seemed to work fine. Until it didn't. And yet again, I had memory problems, and yet again, I couldn't get a heap dump. So what the heck, right? I basically had to optimize the memory blindly based on the changes I had made. So I did a bunch of random optimizations that didn't really seem to work. If anything, they made the problem worse. Yes, so what do you do? I ran it for a while now. Speaking of starting and stopping the crawler, which I had to start and stop the crawler. I ran it for a while, and then I made a heap dump before it actually started killing itself. And I looked at the heap dump, and what I saw wasn't very indicative of anything in particular. My best guess was that there was a bunch of stuff in the crawl frontier, which is basically a queue along with a set that contains information about which websites, or rather which addresses you've visited, and which addresses or links you're intending to visit. And I had implemented this using a linked list and a hash set. A linked list of an object called ECURL, which is basically a more accessible version of a URL than what's available, and it's more optimized to search engine stuff, basically. And these hash sets were of strings, so I made some modifications, and the first modification I made is actually a bit sketchy. It will almost certainly introduce problems where certain links in freak occurrences aren't ever fetched. So what I did was to modify the code so that it doesn't use these hash sets of strings. It uses a primitive hash set of longs, and instead of strings, I'm using the murmur hash of the URL strings instead. And like if you do the math, the odds of a hash collision is very small. You need to basically have 4 billion items in a set before that's particularly likely, and the formula is the square root of the total possible cardinality. And you can look up the birthday paradox, and I'm sure there are videos about it by some very, very informative people. But it's a rule of thumb that's very useful in these scenarios when you need to estimate, like, is it very likely that you're going to have a hash collision? And in this case, the most likely cardinality of these sets is like in the thousands, maybe 10,000 or 20,000. It's not a billion. Like trivially, it's not a billion because I don't have that much RAM. Like I can't have a billion Java objects because the Java object headers are too big, I think, at least. It's very unlikely. Yeah, and I made some other changes as well. Like I removed the easy URL and replaced it with a string and so on. And I removed the linked list and used an array-based queue instead. And I sent it off. And you know what happened? I came back a couple of hours later, and the process was using 24 gigabytes of RAM. Like, huh? What? But this time I was actually lucky because I was able to extract a heap dump, and this was a large heap dump. It was, I think, 20 gigabytes, and the server was very stressed, so it took a long while to actually extract it. So I should be able to like move this file relatively quickly, but it took forever, which is a strong indication that the server isn't very happy. But I was able to load it using a Java has good tooling for heap dumps and just debugging in general. I was able to load it in a tool called Visual VM and able to basically look at what's actually in RAM. And what I found was linked list nodes, like mostly linked list nodes. But what the heck? Like, where are they coming from? Like, in general, you don't use linked lists unless you expect a list very, very small. It was questionable on me to have a linked list in the crawl frontier, but I'd removed them. So why am I seeing linked list nodes? This is actually fairly easy to answer when you have good tooling. I'm just able to look at like who owns this object, and it turns out. Remember how I mentioned I had implemented sitemap support? Well, and also like remember how I mentioned that sitemaps may reference to each other. Yeah, I do. That's foreshadowing. The problem was that some websites have a lot of sitemap objects, like they have an insane amount of sitemap objects to the point where it's able to fill 20 gigabytes of RAM. I don't really know what the heck was going on with those sites, but and I actually knew about this problem beforehand. That's a silly thing. I know like NeoCities has enormous sitemaps for their main server. It basically contains every valid link on every NeoCities subdomain. That's a lot of links, right? Well, knowing this was the problem, it was a super easy fix. Like the problem was I had an unbounded queue, and you really don't want unbounded queues in general. So I just made it check how big is this how many sitemaps have we fetched, and if we have fetched more than 25, then lay it off. We don't need more than 25. Easy fix. And if you're one of the people, possibly the only person who hasn't figured out by now, this is the crawler log we're looking at. So it's running, and it's allocated a fair bit of RAM, but I did a heap dump, and it's not using all too much. That's just Java being Java. The actual memory consumption is down to 2 gigabytes, which is not a lot for a crawler that runs 256 threads. Yeah, so mystery solved. The Scooby-Doo villain has been identified as the sitemap catcher, and I think in part I'm a bit to blame. Well, of course, I'm fully to blame because I built this stuff, but I'm a bit to blame because I didn't really look into it well enough. And this is partly because I pulled the sitemap parsing from a library called Common Crawl, which is where I'm getting my robots.txt parser as well. And in general, I try to avoid building my own parsers if I can avoid doing so, because parsing well-defined stuff, there's really not much things you can do differently than a well-built parser. I invent a lot of stuff on my own, like probably more than most people, but parsers I try to avoid because it's error-prone and time-consuming. Well, I guess I should invent more stuff on my own. I guess maybe I don't know what's the moral of the story. I mean, dealing with the internet in general is very difficult. Like the actual wild internet, you have standards and you have like how it's supposed to be according to the map, and then you have what it's actually like, and it's not even a bit similar. Like any given standard will be broken in 1,000 different ways. Yeah. But I fixed it, and a side effect of this is that I have actually made the crawler use a lot less RAM, which is, I guess, good. Debugging this sort of stuff in general is a bit nerve-wracking, as I may have mentioned. Like if you start and stop the crawler a bunch of times, then you actually revisit the same websites over and over again, and that's not well. It's inconsiderate to the webmasters, and it's annoying to the webmasters, and it's an easy way of getting blocked. So maybe try to avoid that, and I do try to avoid that. But sometimes you have out of memory errors and a half finished crawl and no plan. Yeah, that's the war story of me fixing the crawler. When it started running out of memory. If you've made it through the video, I hope you enjoyed hearing about all the technicalities and so on. I'm not sure who is the intended audience for this video. I just wanted to talk about it. It's fascinating, and I enjoy hearing this sort of content on my own. So yeah, I guess I will see ya. Bye.